discriminant. So, a formula, and here is that formula. It's pretty short. B squared minus 4AC. And the purpose of doing this is because it tells us how many and what kind of x-intercepts that my parabola or my quadratic has. So we're going to fill out a chart. Depending on what we get for our discriminant, what kind of number it is, that'll tell us what our x-intercepts look like. So first off, if my discriminant is a positive number and a perfect square, so perfect square, like the list we have on the board, 1, 4, 9, 16, 25, and so on. Now on the board, I stopped at 144, but perfect squares don't stop there. Okay, there's an infinite number of perfect squares. So if this is true, that means that we have two rational x-intercepts, or roots, or solutions, or zeros. What does the word rational mean? Anybody know? You learned this, I don't know, 8th grade maybe? 7th grade? Algebra 1? I don't know.
Two rationals would have two outcomes. Or like two things that would go into it.
Well, a rational number means that it's it's like a whole number or a fraction. That's rational, like a nice, neat number. That's what rational means. So like -7 is rational. 14 is rational. 2/3 is rational. 1/3. Anything, if the decimal will convert into a fraction, it could be a, 0.333 repeating is 1/3. So if your calculator will convert it to a fraction, it's rational. But if it can't be, like pi is not rational. Pi goes on forever. It's not a fraction. Anything with a square root left in the answer, like square root of 2, if I have this number, 3 square root of 2, I get that decimal. If I try to convert it to a fraction, it doesn't work. That's irrational. It's not a nice, neat number. Okay? So in this case, anytime I have two rational x-intercepts, that means they could cross at whole numbers. So the example I'm going to do here would be on whole numbers. Like this. This would be an example. If my discriminant is a positive number, but it's not a perfect square, so if you try to take the square root of that number and you get a decimal, that means it's not a perfect square. Like 17, 20, 8. Those are not perfect squares, but they're still positive numbers. We would have two irrational. So basically all of the examples that we did where we had to simplify the square root and we had a square root left in our answer, it's like 5.6, that lesson, all of those would have 2 irrational x-intercepts. Now that's going to be, we can't really draw that for sure. So when I draw my 2 x-intercepts, just don't put them on whole numbers. Okay, we can pretend that those are irrational. So just make sure they're not on the line. I mean, it's kind of hard to tell the difference on the graph. But if they're not on the line, then you're okay.
That's so hard to tell.
It's okay. I'm not too worried about the graph, really. If your discriminant, if you fill in the formula and you get 0, that means that you have 1 rational. It doesn't mean that there are 0 x-intercepts. So an example of this would be like when the vertex is on the x-axis. Has 1 x-intercept. And that's always going to be on a nice fraction or whole number. And so then the last thing that I have is a negative number. Doesn't matter if that negative number is a perfect square, like negative 16, negative 25. If it's negative, it's negative. And that means we have 2 imaginary. So the x-intercepts are like the last lesson we did where we had an I left in them. Really, it doesn't cross at all. So it looks like this. It crosses, it's imaginary. We don't see it. It doesn't really cross. And that formula, I'll rewrite it. It's b squared minus 4ac. That's just, I mean, that's just part of the formula.
Every time that we
You're always going to have a 4 there. Yep. That's just always there. Okay. So let's list out our A, B, and C. What is my A? Just you only put the number, just 2. Just 2. B is 12 and C negative 13. Good. So we're going to plug those 3 numbers into the formula. And I want you to write it out. So 12 squared. Make sure you're writing what you're... Minus 4 times 2 times negative 13. Make sure you write this out. If you never put any work and you miss it, I can't go back and tell you what you did or why you missed it. Or if it's a test, you can't get partial credit if you never show any work. I get 248. So that is the discriminant. So if I say, what is the discriminant, I'm wanting the number that you get.
So how you plug it into
So now, that number is going to tell us, we're going to go back to that chart to figure out which of the 4 options it is. So first of all, 248 is positive. But we need to know if it's a perfect square. And it's not on the list, so let's check it. If I take the square root of 248, do I get a whole number? No. So it is not a perfect square. So based on your chart, a positive number that's not a perfect square is what?
2 irrational.
2 irrational.
That would be the answer.
Well, it depends. Both of those are part of the answer. 248 is the discriminant. The type of roots is 2 irrational. So it depends on what it's asking.
We have to graph that?
Huh?
Will we have to graph that?
No, you won't have to graph anything.
Okay.
Alright, number 2. List out your A, B, and C. A is -1, B is 16, and C is -64. So then we can fill into the formula. 16 squared minus 4 times -1 times -64. And we get what? 0. And so what does that tell me about the x-intercepts?
One rational.
1 rational. If the discriminant is 0, it's got 1 rational. It doesn't matter. If it's 0, it's 1 rational. Number 3, list out your A, B, and C. A is 20. B is 7. C is -3. And then we fill in the formula. 7 squared minus 4 times 20 times -3. And we get 289. Now, my list doesn't go up that far, so I need to check to see if it's a perfect square. When I take the square root of it, I get a whole number. It's 17. You don't need to write that 17 down anywhere.
2 rational.
That just tells us that it's perfect and it has 2 rational. Number 4. What's my A? 3. What's my B?
24.
It is not
31.
24. It is not 1.
0.
It's 0. B, your B is the number that's always paired with the plain X. Do you have an X? No, which means your B is 0. C is always the whole number, 24. When we wrote down at the beginning of this unit, we wrote AX squared plus BX plus C. B is always with your X. C is always the number by itself. Oops, I wrote negative there. Type in the calculator. And we get -288. That's a negative number. Doesn't matter if 288 is a perfect square or not.
2 imaginary.
If it's negative, it has 2 imaginary. Now let's take a look at number 5. What do you notice about number 5?
Is your x's on opposite side?
Yes, my 10x is on the other side. That's not going to work. We have to move it over. Has to be with all the other stuff, and it has to go in the middle. So how am I going to get this 10x to come to the other side? We're going to move the whole 10x. We're going to subtract. If I just divided by 10, that x would still be there. So I'm going to subtract 10x. And that goes in the middle. Negative 4x squared minus 10x plus 84. I didn't subtract the 10 from the negative 4, and I didn't subtract the 10 from the 84, because those are not like terms.
Just switch the
It just
side.
goes, yeah, basically you just switch the side and put it on the other side.
Which x goes first? The one on the end.
The x squared is always first, and then the x, and then the plain number. So B,
Negative 10.
negative 10, C,
84.
84. So I wrote out my formula. Now type it into your calculator. And you get 1,444. I definitely don't know off the top of my head if that's a perfect square. So what I do is I take the square root and see if I get a whole number. And I got a whole number, so that means it is a perfect square. The positive perfect square, which means it's 2 rational. Any questions? Okay. So last one, I have this negative 2 is on the wrong side. So how do I move it to the other side? Add 2. Because this is a minus, so I do a plus. Now I don't do negative 3 plus 2 to get negative 1x. Those are not like terms, so you just write them all separate. 2x squared minus 3x plus 2. So now I want you to work by yourself to try to finish this problem. So when you type that in, you should get negative 7. Which means 2 imaginary. Any questions?